All right, so we're going to go through your notebook, and sorry, this is, I'd love for you to do this along with me. Sorry that it's kind of a lot of text. So there's kind of three main sections here. So section 1, section 2, and section 3. And our plan today is that I will do sections 1 and 2 with you, and then you can go ahead and try 3 on your own. So LeChatelier's principle says that if you stress a system at equilibrium, the reaction will proceed to counteract the stress. And in class today, we learned that, for instance, if we zoom way in here, if I were to add more and more and more reactants, the reaction will proceed. When I say okay, go, the reaction is going to proceed to make more products. And if I, on the other hand, add more products and more products, and I just dump ammonia in over and over, and I said, okay, go, then the reaction will proceed to make more reactants. So those are a couple examples of how we can stress a system and then it responds. So the reaction for the graph on the right is right under here with number 1. And when we look at this graph on the right, we know that equilibrium happens anytime the concentrations are no longer changing as a whole. So we would see that equilibrium would be happening here and here. So it's happening twice. So the reaction is at equilibrium. Maybe we can just point, if you draw this in your notebook, to those two spots. Which substance is added at time 2? So right at time 2, if we look at this graph, one of the substances, so we're looking at either H2, N2, or NH3, right at time 2, one of those substances increases sharply, and that would be the blue line, the hydrogen. So the hydrogen comes along, and then all of a sudden, boom, a big jump. And so we would conclude that because there's a spike there, the substance that's added at time 2 is hydrogen. Now, from time 2 to time 3, letter C here, what happens to the amount of each thing? So we'll just zoom in over here between time 2 and time 3. So we're looking just in this window here, what's happening to the substances. And we could see that the blue goes down, yellow goes down, red goes up. So we would say that hydrogen decreases, that's the blue. The ammonia, NH3, that's the red line, that goes up, so this would increase. And then the N2, the yellow line, goes down. Okay, now back from what I said at the beginning, if we saw that there was a big spike in hydrogen, so this blue line here, if we see there's a big spike in hydrogen, and we could say okay, if I would add a bunch of this and a bunch of this and a bunch of this and a bunch of this, and I say, okay, go, if I'm stressing this left side and saying I'm adding more and more and more and more, once I say, okay, go, the reaction is going to proceed to make more product. So we would expect that the amount of NH3 goes up, and look what happens. It increases. That's a terrible color. Okay. The amount of NH3 goes up, and then also up here, if we see that the reaction is going to shift to the right, then the amount of N2 and H2 left should go down. So these should decrease. So those 3 answers below match with what we discussed earlier, the responding to a stress. All right, last question, letter D. If I increased the concentration of NH3 at time 4, what would happen to the concentrations of N2 and H2? Okay, so we see that at time 4 here, we're at equilibrium, so everything is kind of back to balanced. And for part D, we're actually going to be using the balanced equation, and I think that's just a little easier that way. So if I increase the concentration of, we'll go with a different color here. If I increase the concentration of NH3, so that means that I make this here, and I make it bigger and bigger and bigger and bigger and bigger. So and then I say, okay, go. If I've increased the amount of NH3 so much, when I say go, the reaction is going to shift away from that stress. So we would expect more N2 and H2 to be made. So we would say they will go up. They will increase. All right, number 2, almost done. The following reaction is currently at equilibrium. So that's this reaction here. This is at equilibrium. And that means that it's already reacted, and now it's just going back and forth at its balanced rate. So now it's going to say, like, can you fill these in? If I do this at equilibrium, the reaction will proceed to make what? So if I add more lithium chloride, so I'm going to do this again with kind of the highlighted things. So here's the lithium chloride, and if I add more and more and more and more, and I say, okay, reaction, go, respond to this stress. So if I just added more and more and more, I'm stressing the left side, and so it's going to shift to make more of the right side, which are the products. So we would say more products. Next question. If we add more lithium nitrate, what will happen? So here's the lithium nitrate. And so if we add more and more and more and more lithium nitrate, and we say, okay, we're stressing this right side. When I stress this right side, the reaction will respond to relieve that stress and turn that right side back into reactants. So we would expect to see more reactants if we just add a bunch of lithium nitrate. Finally, what if we remove some LiNO3? So let's say we started out with this, and all of a sudden we can move it. Maybe we're evaporating it, filtering it out, and we take it away, take it away, take it away. Oh, it's going to be gone. And so if we want to make more of it, we're stressing the right side really by removing lithium nitrate. The reaction is like, hey, we want to go back to balanced. We'll make some more. So the reaction will shift to make more products. So there's part 1 and part 2, and you can try part 3 on your own and check for a key online.